ערב טוב. כל האמיצים שנשארו מהבוקר, יש כאלה שאין להם ברירה, וכל מי שהצטרף אלינו עכשיו הפך להיות מסורת בכנסי החלל, פאנל של אסטרונאוטים. האמת היא שיש לנו היום פה בסך הכל מספר אנשים מכובד ביותר שהיה בחלל במשימות שונות ומגוונות, ואנחנו קצת נשאל אותם שאלות, ובמידת האפשר נשתף חלק מהשאלות שיגיעו מהקהל. ולידי הלן וקסלר שתשתתף בהנחיה, או שאני אשתתף איתה. אז בבקשה תציגי את הדובר הראשון.
תודה. I'm really excited to invite to the stage astronaut Dr. Donald Thomas from the USA. Dr. Donald Thomas is a former NASA astronaut. He earned a Master's of Science degree and a doctorate in materials science from Cornell University. In 1987, he worked for Lockheed Engineering. He worked for Lockheed Engineering, where he reviewed materials used in space shuttle payloads. A year later, he joined NASA's Lyndon B. Johnson Space Center as a materials engineer. He was also a principal investigator for the microgravity disturbance experiment, a mid-deck crystal growth experiment which flew on STS-32 in January 1990. Dr. Donald Thomas became an astronaut in 1991 and served in the Safety, Operations, Development, and Payloads branches of the Astronaut Office. He was Capcom spacecraft communicator for shuttle missions STS-47, 52, and 53. From July 1999 to June 2000, he was Director of Operations for NASA at the Gagarin Cosmonaut Training Center in Star City, Russia. A veteran of 4 space flights, he's logged over 1,040 hours in space. He's also a private pilot with over 250 hours in single-engine land aircrafts and gliders and over 800 hours flying as a mission specialist in NASA T-38 jet aircraft. Thank you for being here with us today.
Thank you all. Thank you.
And Tal will invite our next speaker.
Okay, our next speaker is NASA astronaut Dr. Michael Barratt. Please take your seat. Dr. Barratt was selected by NASA in the year 2000. He earned a Doctor of Medicine from the Northwestern University and completed a 3-year residency in internal medicine in Northwestern University in 1988. He completed his as chief residency year at Veterans Administration Lakeside Hospital in Chicago in 1989. Dr. Michael Barratt is certified in internal and aerospace medicine, so if there is an medical emergency here during this panel, we have more than one doctor, and you will hear about it in a minute. And he was a flight engineer for Expedition 19 and 20 aboard the International Space Station. This marked the transition from 3 to 6 permanent International Space Station crew members. During his time, Dr. Barratt performed 2 spacewalks and flew on the STS-133, which delivered the permanent multi-purpose module and Fort Express logistic carrier. Currently, Dr. Barratt serves in the International Space Station operations and integration branches to handle medical issues and on-orbit support.
I'm excited to invite astronaut Dr. Thomas-Henry Marshburn from the USA to join us here on the panel. Dr. Thomas-Henry Marshburn received a master's in medical science, University of Texas, and engineering science from the University of Virginia. He also earned a doctorate of medicine degree from Wake Forest University in 1989. He is trained in emergency medicine and was certified by the American Board of Emergency Medicine in 1992. Dr. Marshburn came to Houston's Johnson Space Center in November 1994 as a flight surgeon, assigned to Space Shuttle medical operations and to the joint U.S.-Russian space program. From 1998 to 2000, he was deputy flight surgeon for the neuronal STS-98 and lead flight surgeon for the STS-101 mission to the International Space Station. In 2004, he was selected to become an astronaut by NASA, and he completed astronaut candidate training in February 2006. Dr. Marshburn completed his first space flight in July 2009, logging more than 376 hours in space and 18 hours and 59 minutes of EVA in 3 spacewalks. He also launched to the International Space Station as a flight engineer in December 2012. Thank you.
And to complete this fabulous panel of space travelers, I'm honored to invite, by the way, for the second time, as well as Don Thomas. He was here last year. Astronaut Dr. Z'An Favier from France. Z'An Favier is also a doctor, but not in medicine. He got his PhD in metallurgy from the École des Mines de Paris and a PhD in solid-state physics from the University of Grenoble. Dr. Z'An Favier was an astronaut on the mission STS-78 back in 1996 and flew for 17 days in orbit. He worked as a scientist with the Commission of the Atomic Energy of France from 1976 to 1999. Also, Dr. Favier is a co-founder of the company Blue Planet, an innovative company aiming to develop a new concept of microsats constellation covering the entire globe with a resolution of 1 meter every week. He is the recipient of the French Légion d'honneur, the NASA Flight Medal, and the Gold Medal of the city of Grenoble.
Kind of obvious question, but did you guys always know that you wanted to be astronauts?
Well, I'll start. The easy answer is no. I became interested in being an astronaut in my mid-30s, and that's probably unlike most people, but a message to all the adults in the room, it's never too late to make a radical career change to do something very exciting.
Okay, in my case, of course not, but I remember when I was a kid, I was 12 years old, when the first human left this planet. It was Yuri Gagarin, and he did it just the day before my 12th anniversary, birthday. So I remember that, and of course, I thought that these guys were just superheroes. It was no way for me, actually, to make what they were doing. But as you said, years later, decades later, actually, I was involved in the space program as an engineer and a scientist. And when the space agencies were looking for profiles like mine, so I applied. I was lucky to be selected.
And in my case, yes. Most of my life I did want to be an astronaut, although I never would have thought that I would be able to be one. So my goal was to just have a chance to work for the space program. So I went a circuitous route, engineering and then medicine. Showed up at the Johnson Space Center and thought, well, maybe I could do this job. And after 4 tries, 4 applications, I was finally able to join the astronaut corps.
And I was 6 years old when I knew I wanted to be an astronaut. I watched the first American launch into space on May 5th, 1961. I watched that on a TV at my school, and I knew at that moment that's what I want to do. And it took me many years and 4 tries as well, just like Tom, to get into the program. And I was 39 years old the first time I made it to space. So it was a long journey from 6 years old, just dreaming of it, to making it to space, but it was worth all the hard work, all the effort along the way.
So just a quick follow-on question about the challenges they all have to overcome to become an astronaut. Not all the applicants get the chance to fly in space as a smooth way.
I have to say that for me and for most everyone I know, I think in all of our careers, we probably knew throughout our careers hundreds of people that wanted to be astronauts along with us in our graduate school and our training. And we all loved what we did. And that's what I tell kids. Wanting to be an astronaut gives you several things, one of which is you develop an education in a field that hopefully you love and is going to be of great use to you. Throughout my hope to be an astronaut, I also knew that I had a career that I loved and would be of benefit to others as well. So there was really no downside to wanting to be an astronaut, even if I were never selected.
One interesting twist for Tom and I recently is that we were very lucky, very blessed to get selected to be astronauts. One of our recent jobs was to help select a new class of astronauts. And when you're looking at numbers, we received over 18,000 applications, and we had to pick 12 people from that list. And when you get down to the final 200, all of them are excellent people. All of them can do the job. All of them are people you would want working for you, and it's extremely difficult to parse out only 10 or 12 people from that. It makes us all feel very humbled and very lucky to be doing the job we are. But don't be discouraged if you want to do that.
The only thing we tell people, the only thing you know for sure is that if you never apply, you will never become one. But that's all you can be sure of.
You got to play to win.
When you guys finally got to space after all that training, was there anything that really surprised you when you got there that you weren't prepared for?
I think the view of the Earth that I saw looking out the window for the first time, we receive hundreds of hours of training on Earth observation, taking pictures of the Earth, and I'd seen the IMAX movies of planet Earth, so I thought, I know what to expect. But when I went to the window for the first time and looked out and saw the Earth with my eyes, I gasped. It was, wow, it's so incredible. It was just more detail that I could see with my eye than any picture I've seen, more subtle color variations. And that shocked me. I really thought I knew what to expect, but when I looked to the window, I did not.
I think I would say the first 5 minutes nobody prepares you for. So my first flight was in the Soyuz, and 8.5 minutes of rocket ride, rocket acceleration, all of a sudden the engine's cut off. And in those first few minutes, you are suddenly weightless, and all the fluid shifts to your chest and head. You feel a rush to your head. You also have to ensure that your spaceship is healthy, that there's no leak, there's nothing wrong with it, that you can stay in orbit. So you're absolutely focused, concentrating on the health of your spaceship. And in the Soyuz, we actually rolled over and I saw the Earth for the first time. It's every bit as magnificent as Don said. And I started to feel just a little bit queasy. All of those things are happening at once. And you know that all of them are going to happen at some point, but the combination is quite amazing. So I will never forget my first 5 minutes in space.
Yeah, for me, it was also something very comparable with what has been said. Well, in my case, between the first selection by the French Space Agency and my flight, it took me 11 years, okay? So I was back up on Don's flight, so we trained together for 2.5 years and so on. So I was used actually to get in simulators and to get all the environment that we are supposed to get in space. But I remember also my first job on the shuttle was actually to go to the window and put an UV filter on it. So I went there and I looked down, and we were just over Africa. I said, "Wow, this is not a simulation this time. This is true."
My first few minutes were a little chaotic. I was in the mid-deck of the space shuttle, And I think we all rehearsed the first few steps of any big task like a spacewalk or arriving into space. And I had rehearsed in my mind, all right, I'm going to take off my helmet, I'm going to take off my gloves, I'm going to put the gloves in the helmet, I'm going to reach under the seat, get a bag, and put the equipment in the bag and then put it back down. And so when I arrived in space, you feel all the zero G, the fluid go into your head, but I made a big mistake. I undid my seatbelt. So I took off my gloves, my helmet, reached under my seat, flipped upside down, found my head up under the seat, and was completely disoriented at that moment. So it's the zero G aspects. We're very much, if I could remember what it was like to be a toddler again, that's probably what we felt like then, trying to learn how to walk and move around again. All, as Mike said, all of that's happening all at once. It was quite fascinating.
We heard earlier about the Space Club, and at the first space missions, first decades of the space race, it was a national issue. Either you were a Soviet cosmonaut or American astronaut. So, but some of you had the opportunity to work with different types of space training, space hardware. So how could you describe the differences and the similarities between the way that the Russians, meaning Soviet and then Russia, conduct space flight compares to the American way, not only on the space wise.
Well, the biggest issue is that they speak Russian, for crying out loud, and we don't. At least we didn't. Yeah, exactly.
Really good at it.
Really, the language barrier is one of the biggest things that we had to overcome. And Tom and I both started working with our Russian colleagues in the 90s during the Shuttle Mir program, where we flew Russian cosmonauts on the shuttle, we flew US astronauts on the Mir station. And you take people who are in their late 30s or early 40s and say, learn a new language. It's Russian. You must be proficient because your life may depend on it. That's difficult. And of course, they had the same issue learning English. So we had lots of cultural issues, but I would say the language barrier was one of the hardest for a lot of people. And I'm just scratching the surface to leave room for my colleagues here.
The approach to training is very practical on the Russian side. Obviously, it's true for both, but in Russia, if it's not broken, they don't fix it. They do it the same way. When we were in training over in Russia, the gentleman that probably taught Yuri Gagarin orbital mechanics is in his 80s. He's sitting at the back of the room watching the young gentleman that's teaching the course to us. They rely very heavily on this heritage, this person heritage, as opposed to documents that we might save and hand on to the next generation of teachers. So the teaching, the education was quite a bit different there, but the similarities are immense, particularly when it comes to what is important when we're up in space, the survival, missing our families. When you get together around the dinner table in space, you realize we are much more alike than we are different, particularly when it comes to missing home and thinking about our families.
One kind of follow-up is that Russian hardware tends to be only as complicated as it needs to be. It's very simple, it's very reliable, and very robust. And Tom and I both had the honor of launching from the same launch pad that Yuri Gagarin launched from in 1961. Why? Because it worked. A very simple, elegant system of cantilevers and supports that just work beautifully and have for decades. And the design of the Soyuz hasn't changed much for decades. Why? Because it works. So we have learned a lot from our Russian colleagues on the approach to practice and hardware. Keep it as simple as possible and keep it as fixable, as able to be repaired on board as possible. I think we've actually learned a lot from each other.
There was some mention of being in space and seeing Earth, which I imagine was an amazing experience. Did that give you new insight on life? Did you have like an epiphany moment when you saw that?
You know, I don't know if it gave me a new insight on life, but the whole experience of flying in space, I think it changes astronauts in two ways. The first is that you see how fragile the Earth is. You see the thin atmosphere. I could see the cutting and burning of the rainforest. Nearly the entire continent of South America was under a smoke pall. And that really made me appreciate what humans are doing to our planet. So every astronaut changes, and how they appreciate how fragile Earth is. The second thing that changed for me was how I view my place on planet Earth. I grew up in Cleveland, Ohio, and I would always tell people I'm from Cleveland. That's how I identified myself. But today I would say I'm from Earth. And to me, it doesn't matter what city or state or country or continent you're from. It doesn't matter what religion you practice, that we are a lot more similar than we are different. And we all have this responsibility to take better care of planet Earth. Thank you.
And similarly, I'd have to mention the interconnectedness. You might be looking at a dry lake bed in Chad, in northern Africa, and you see the dust coming off of that, and you can actually see the front blowing across the Atlantic that's going to be hitting the U.S. In 20 minutes or 40 minutes, you go from a place of relative calm to an unstable place of the Earth. It felt very interconnected with the human race, and as has been mentioned, we seem very extremely fragile. The Earth looks big from space. We can see the curve of the Earth. When you imagine the immensity of the sphere below you, what you see is incredibly beautiful, but it also feels like our place on it is incredibly fragile. And that was one of the things I came away from it.
Yes, one follow-up is I think anybody's perception of a really amazing experience is very dependent on who you experience it with. And we work internationally now. The International Space Station has countries of Europe, and of course we have Russia, Japan, Canada, the US. My crew had people from all of those agencies. We had 2 Russians, a Belgian, a Canadian, a Japanese, and myself. And we all just got along incredibly well, sharing this amazing experience. And while we were doing this, there were hundreds of people on the ground from all of these countries working together every day across the barriers of language and culture. We've had several intermarriages now because of the International Space Station, and it's resulted in children who are now graduating from college. To me, one of the greatest spin-offs of the space station program is the cooperation that goes along with that. And certainly some of my best memories are just being around the galley table with this very international crew, and we all come away thinking, why can't we all get along this well all the time?
Yeah, and from space, actually, you don't see any border between countries, and therefore we have really the impression that we belong to the same small spaceship, Earth, and the fragility of it has already been mentioned. I remember also the South Africa and the fires in Amazon and so on, these places. And when I talk about this to people, to friends in France or in other countries, they say, okay, but South Africa is very far from France, okay, this is no concern for us. But with a spaceship, actually, it took us just 10 minutes to go from South America to Europe, So it's just the door, the other door, So I realized that, and this is the kind of message I try also to pass to the young generation.
So actually I have a specific question for Thomas. You were in the first class of the NASA Space Medicine Fellowship Program, and at one point in your career, you were tasked with managing the ISS health maintenance system. Can you elaborate on some of the challenges of maintaining crew health in space?
Well, one of the biggest challenges as a doctor, I wonder how good would I be being a physician if I didn't have all my toys, if I didn't have the emergency room and all the equipment that's in that. So in space, you have very limited volume, power, even expertise. You may not even have a doctor that's on board. So the biggest challenge was figuring out what exactly do you need and how can you provide it in the most efficient means possible, even when you don't even have a doctor on board to administer health care. And so several approaches, either whittling down a big, huge ICU down to the essentials, or going the other way, building up what are the medical problems we face, what are the challenges, and going from there. Turns out one of the best things you can do for healthcare in space is to select people that don't have disease that they bring on board with them. Trauma, other diseases could arise. Turns out space is, very commonly people get things in their eyes. Space is hard on the eyes. It can be hard on the hands. Usually minor trauma, but you could imagine somebody getting a finger caught somewhere and getting getting broken. Space is hard on certain parts of the body, and so we concentrate on that, and then we have worked very hard on figuring out the most efficient way, say, to do surgery. We probably will not do surgery in space in the classic sense, but maybe using needles and very closed, controlled techniques to take care of some problems. We're going to have to accept some risk up there regardless, particularly as we go on to Mars. But those are the kind of challenges that make the field of space medicine so exciting, is trying to overcome these challenges and come up with solutions.
Thanks. I have another specific question for you, Z'an-z'ac. So you've been a principal investigator on so many experiments, and you've done research with ESA and NASA and even the Russian Space Agency. What's been your favorite experiment and why?
Well, a difficult question. I've prepared more than a dozen of space experiments. My favorite maybe is the one that I have developed with my team in my laboratory in France. This was actually the follow-up of my PhD thesis, okay? And I was able actually to convince the space agencies, first the French one, then NASA afterwards, to fly an experiment on this same principle. So we have developed in my lab the engineering models, then the space agency, the CNES, has developed the flight models, and NASA flew the experiment on the space shuttle. So I'm one of the few scientists actually who have prepared their own experiments in the lab before the flight, had a chance to develop the flight models, the chance to fly them, and after the fly to come back to the lab actually to analyze the results of the experiment. So I made the full loop, and for a scientist this is something which makes sense.
That sounds really cool. And was that a benefit that you had from waiting a long time to fly that enabled you to do more research before you were sent?
Yeah, of course. I mentioned the 11 years between my first selection by CNES in France, then my flight. In between, I had 2 selections by NASA for being a backup first and then prime. But in parallel to that, of course, I was continuing my research. Okay, so the topics and the experiments that I have performed during my flight were prepared during these 11 years.
Don, you claim to be the first person to eat pizza in space. Can you tell us more about pizza in space and in general about food in space?
Yeah, I am the first person to take pizza into space, and on my first flight, on all of our flights, they let us carry a sandwich in our suit out to the launch pad because of weather delays. We may be out there for a few hours, so they let us take a sandwich. And I asked on my first flight, well, can I take a slice of pizza? And my commander said, no pizza. So I flew pizza-flavored goldfish crackers instead, just out of protest. But on a follow-on mission, I asked my commander, can I fly a pizza? And he says, yeah, that's fine. So in our crew quarters that make our food, for in a lot of we eat in the crew quarters, our dormitory there. They made a little personal pizza, had it in a Ziploc bag. I had it in my pocket. It's nice and thin, and with the congealed cheese, it wasn't a lot of crumbs. So I was the first to fly pizza in space, and I'm so proud of that because it's one of my favorite food groups there. In general, the food, I say, is just okay in space. I would never go to a restaurant that serves space food. So you don't want to go up there for the food. You want to go up there for the view, for the experience, for the camaraderie, but not necessarily for the food. But the pizza was great. And it was double pepperoni if it ever comes up on trivia night. Okay?
I would like to hear from either of you about the moment you entered into Earth's orbit and you became weightless. What was the process of adjusting to this new situation? And if it was for the second time in space for you? Was the experience somehow different?
My second time in space, it was like I'd never left in terms of how it feels when you get up there. My experience, the moment you hit orbit, and by hit, I mean you reach orbit and your engine cuts off. You go from this chaos of the rocket firing behind you, the pressure of the G's, and then suddenly the main engine shuts off and everything's quiet. You hear a little fan going, but other than that, it's complete silence. And then fluid goes up into my head. Our bodies are meant to, our heart and our systems work to push blood into our heads so we can stand up here on Earth, and so when you hit space, it keeps on working and it pushes it right up into your head. So I felt like I was tilted backwards a little bit. I described being disoriented a moment ago. Over the next few hours, I found myself hitting my head constantly against the top of the cabin, and I realized finally that was because my legs kept extending as if it wanted to stand up, and it kept, like an invisible hand, kept smacking my head against the top of the cabin. But over a few days, you learn how to translate, you learn how to fly around in zero-G. There are a lot of funny things that happened in zero-G to everybody. In zero-G, the hard things on Earth, like lifting something heavy, is really easy. But the easy things on Earth, like where to put your pencil, where to put your cup of coffee, that is really hard in space. It's just hard to figure all that stuff out.
I think I've spent a total of 7 months in space, and in that time I've seen 32 other people besides myself. And some of them had previous spaceflight experience, some of them were brand new, and it actually became a source of amusement for me to watch people come for the first time and do what Tom did, what I did, certainly. And you can watch and you can see the steps of people adapting and adjusting, and it's very predictable. The time changes for various people, but it's very predictable, and it's quite interesting. And typically the order, your sense of balance gets you quickly. We get a kind of a seasickness, a space motion sickness, and then you actually start to lose some of that fluid from your body, and you feel better. Your head doesn't feel so congested, and over a much longer period, you become a three-dimensional creature. So you lose that idea that there has to be an up and a down, and you have to go this way or that way. All of a sudden you go this way and that way, and you may roll this way or yaw this way or fly whichever way you want. And it's really quite amazing that we can become these three-dimensional creatures. But I agree with Tom and Don, you've flown 4 times, but certainly the second flight was amazing because you remember, your body remembers, and you have strategies that help you do things right. And so seeing somebody whose experience is just amazing. They adapt very quickly.
I had a strange sensation my first flight as soon as the engines cut out and I unstrapped from my seat. I had the sensation that I was levitating, floating upward. And I would pull myself down and put my feet on the floor of the shuttle and let go, and still I had this feeling I kept moving upward. And I compare it to a situation I had when I was younger. I broke my arm and I had a heavy plaster cast on my arm. And I remember the day the doctor cut the cast off, I felt like my arm did that. It didn't go up in the air, but not having that weight pulling down gave me the sensation that it was levitating, floating upward. And this lasted for me on the shuttle maybe for 45 minutes, you know, that first time in space. And then it went away and I was just used to floating there. But without that pull of gravity, I had the reverse sensation I was going up. But again, second mission, third mission, as soon as I got up there, you feel right at home, you remember about it, and you know, you get right back to work.
And what happens after you land back on the Earth, except for the obvious difficulties to walk and so on, but do you bring with you some habits that you gain in space? I remember speaking to Jeff Hoffman some times ago, and he always mentioned that he drank coffee at home and left the mug, and suddenly he was amazed to see some pieces of ceramics in the coffee on the floor. So
that only happens to our colleagues.
Yeah.
Never to us, no. But on one of my missions, we spent the night at the Kennedy Space Center. My family was there, and in the middle of the night, my son, who was 2 or 3 years old, was crying, and I woke up from a deep sleep. I didn't know where I was, but I heard him crying, and I walked to the room where he was, and I felt like I was walking through maybe 10 meters of deep snow. it was just so hard, and I couldn't realize, like, why is this so hard? I just wanted to float and get there, and yet I just felt so heavy. Part of it, I was, half asleep, but getting used to the gravity, the pull of Earth, I felt like I weighed, 1,000 kilograms coming back.
Yeah, I had the same feeling. I was lucky not to be sick in space, in the sense that I was very careful during the 3-4 first hours. I knew from the other astronauts that we had to be very careful. And just to give you an example, in the shuttle from the middeck, to go from the middeck to the flight deck, there's a ladder you use when you're on the ground. And in space, you just push with one finger, you can change. Oh, sorry, and you can change. So I used the ladder in space for 3-4 hours, and I was not sick. So I decided after a while, for the first time, actually to swim in space and in such a way that I have never been sick at the time. Coming back on the ground was very tough. I'm not a medical doctor myself, so I was discovering the behavior of my body, when experiencing. So, well, when I flew, I was 47 years old, okay, meaning that my body for 47 years was used to get gravity, okay. So I went to space only for 17 days, and after that, my brain was unable to remember how to behave in the presence of gravity. So it took me about half a day to 1 day, actually, to remember how to walk, just what Don was saying. And this is just incredible for me. But the good news is that I realized that the body actually can adapt very easily to a new environment, okay? So there is some plasticity in the brain, and this is what we will use probably for long duration flight and exploration in the future.
So after you've become an astronaut and you go to space and you come back down to Earth and you recover and you can now walk again and are readjusted, career-wise, like, what do you do after you become an astronaut?
You fly again.
Not as long as you can.
Most of us, or many of us, want to fly again. And for many, it's interesting. The first time you fly in space, there's the anticipation, when will I be selected? And then your classmate gets selected and everybody cheers, but then it's even more. Okay, when is my turn? After you fly, that doesn't go away. I was fascinated to find out, because in some ways, the success of the first one is indicated by assignment to a second mission. So there's always that anticipation for selection even after the first one.
And this is true also, even for people like me, scientists who are not professional astronauts. If you tell me tomorrow you have a chance to fly again with your experiments, I just go.
And I think you need to find another passion that you really care about. All of us love space, and we wanted to be astronauts. We wanted to go into space. We had a passion for that most of our lives. And when it becomes time to retire from the astronaut program to do something else, you have to find that other passion, something you really enjoy. And for me, it was education. NASA used to send us out to schools. Once a month, we would go to a school to give a presentation. And I learned that I really enjoyed that. It energized me. So when it was time to think about leaving NASA, I thought, I'm going to head into education. And I left about 11 years ago. There hasn't been one day that I sat there and said, boy, I wish I had stayed at NASA. Because I have this new passion. I love what I'm doing. And that's just what you need to look for. So when it's time to quit flying, you need to have that passion. But you want to fly as much as you can, that's for sure.
We spoke earlier about some new enterprises in space, especially private space. How do you see the next phase in the human space transportation to space via commercial vehicles like the Dragon 2 or the Boeing Starliner and so on?
Well, some of that is very easy to describe because these are programs that are happening right now. And I want to back up. The last time we designed a new spaceship was the space shuttle, which was designed and built in the 70s and began flying it in the 80s. So, wow, that was a long time ago. After nearly 30 years, we're now building new spaceships, and not just one. We're building many new human-rated spaceships. The Boeing Starliner, the Dragon 2. We've also got a raft of suborbital vehicles, which will take space tourists to space for a few minutes anyway. And we're building another deep space vehicle, the Orion, which will take people to the moon and hopefully potentially to Mars with a habitat. So there has never been a time in history like now where so many new spaceships were being built for people. And the big enabler is indeed the commercial sector, because the commercial world can do things that we can't, first of all, because they're free of government regulations. But I think most importantly, which people miss, they're not starting from scratch. They're not starting from the beginning. They have been given all of NASA's technology and understanding, and they're using that to build a new base and a new way of doing things that really should be cheaper and faster. And the biggest beneficiaries right now, it's us, it's our agency. And actually they're building vehicles for us. And when you also think about the market, we're the market. There's no other place to go in low Earth orbit but the International Space Station. So this really helps us. But once we build these new ships, then it incentivizes new low Earth orbit platforms, which will have nothing to do with NASA or the Russian Space Agency. They will be commercial. And it gives them a reason to build these stations because now you have a way to get there. So I think we see private enterprise taking over low Earth orbit in the very near future, and that is a good thing for us for two reasons. It builds infrastructure and redundancy, and it frees us up to go do what we do best, which is explore. It's going on to the moon, going on to Mars. So I think we see big benefit, and I think we also see big opportunities in the commercial space world. It's no longer just a purview of government agencies. Lots more participation.
How widespread do you think that's going to be? Do you think space flight will be accessible to the masses in our lifetime?
Absolutely. Certainly even within our lifetime. A lot of people are not aware of what Mike described. And in a few years, hopefully the next year or the succeeding year, it's going to hit, in my mind, like a thunderclap. Wow. This just happened. A private company sent U.S. astronauts to the space station, and they're going to be advertising to sell tickets. And those are going to be expensive, but every major phase of transportation has been that way. People with a lot of money it used to cost, what, $15,000 to fly from the West Coast to Hawaii in some of the first charter flights that went over there. And, but that's what's required, and eventually everyone, I certainly think that later in life myself and everyone in the audience will be able to buy a ticket to fly into space. Certainly our children and the next generations will see this as the dawn of that era.
Until that happens, the astronauts are still going through big space agencies. And I imagine we have quite a few aspiring astronauts here in the audience. We talked about the fact that astronaut selections is so competitive, but can you elaborate a little bit more on that process? Like, what does it look like? How long does it take? What are they looking for?
It starts off with a government application. If you want to be work for the post office, work for NASA or everything, it's the same form you fill out. NASA's interested a little bit more in your physical health, so you have an aviation medical examiner, usually a local doctor, to provide a report to NASA. But after that, it gets quite interesting. I'll let some of my colleagues talk about that.
There are a lot of different profiles needed actually to take part in an exploration program. So therefore this means for the young generation that any discipline, scientific discipline mostly, has a meaning in this context, and therefore you can, if you are more interested by engineering, make an engineering degree, piloting also, of course, but the scientists, the physicists, the medical doctors, even in my flight, I was lucky in case I get sick because I had 2 medical doctors plus a veterinarian. So, yeah, so I flew with a veterinarian. Just to let you know that actually even this kind of of a job is used by NASA and other agencies. Maybe one recommendation for the young generation: try to get at least two backgrounds or two complementary backgrounds, because this helps a lot for the selection. Engineer and scientist, pilot and engineer, medical doctor and engineer or whatever. So this helps a lot. So try to get multidisciplinary, and this will help you for a selection. Yeah.
Yeah, I would mention that we had our 18,000 applications, and in our astronaut office of about 42 people, it was really primarily us who went through these applications to choose our next class. Starting with 18,000, we eliminated about 6,000 right away because they weren't quite qualified. Well, that leaves you 12,000. And of those, each application was read by at least 2 astronauts. And of those, 2,400 or so were medical or biological. So that's what Tom and I did for several months. And we looked for exactly what Z'an-z'ac said, people who were versatile, who maybe had 1 or 2 different degrees that were of interest to us, but also experience in very uncomfortable places, either expeditions, working in Antarctica, or working in field science research, or just experience that showed that they were capable in an uncomfortable place. And of those 12,000, we chose 120 or so. And again, when you get down to that 120, you know that all of them are qualified. We invite them all down for interviews. And I will just tell you that by that time, you're looking for somebody that you could lock yourself in a small room for 6 months with and not kill each other. So it's very much down to the personality, the comfort level, the confidence of the person, how much of a team player they are, knowing that all of them could potentially do the job. From that, we chose 12.
And from that interview process, there's a 1-hour interview. So you pass the medical tests, and then based on that 1-hour interview, they select their final astronauts. And I'm in there doing my 1-hour interview, and they start off asking very easy questions. Tell me what you did after high school. And they'll ask, why did you choose that university? And what sports did you do? And then near the end of the interview, they started asking me some, what I thought were stupid questions. They said, what shoe do you put on first in the morning, your left shoe or your right shoe? And I'm thinking to myself, you know, we have 1 hour in here. Why are we talking about these stupid things? And I used to paint houses in high school, and they asked me during the interview, what paint do you like best, latex or oil paint? And there was a series of these stupid questions, and you want to explode, but I realized what they were doing. They were intentionally asking me a series of stupid questions and watching my reaction. And I decided, if you want to talk about what shoe I put on first in the morning, we'll talk about it. And I just went through that, and that's what they were looking for. So you just never know. You know, it's a very easy interview, very comfortable questions for the most part, but you want to make sure you don't explode if they ask you 2 or 3 stupid questions in a row.
But we are all curious, what shoe? Left or right?
I think I said right,
Yeah.
but I don't know.
That was the right shoe.
Actually,
That was the
left
right
is
shoe,
the
yeah.
right answer.
So imagine how difficult it was already for American applicants talking to American or Texan physiologists. Imagine for a French guy like me to understand what the questions were and to get to the right answer.
You got the right shoe also.
Could you please elaborate a little bit for the audience about the ground training, not the physical, not the emergency procedures and so on, but the preparation for an expedition on the ISS, for example, when you have to conduct a lot of very different types of experiments, and those are not, like Z'an-z'ac said, his own experiment. You are basically researchers and extensions of a lot of researchers and scientists on Earth. So how is the daily work towards an expedition in space?
I think one thing I learned as a medical doctor, we trained to, we have 2 years of classes, big stacks and piles of books, and you read through all those, do the best you can on those tests, get to know the knowledge, and then you spend 2 years practicing it. To get ready for space flight, it had to be much more efficient than that. And so for me, you'd go through all of these, the training on all these experiments, all these topics, how to fly, how to do spacewalks, knowing full well you'll probably remember just a small percentage of that. So you try to lock into the one thing that's going to stick in your mind more than anything else. And I think each of us would have this little tiny checklist. If nothing else, I've got to remember this and memorize that. And a lot of things do come back. Over a year and a half to 2 years of training, a lot comes back. And of course, the ground's there to help you. The procedures are there to help you. But you learn how to be incredibly efficient in just trying to remember the things you need to at the important moment while you're up there.
Yeah, I think a good point is that if you learn something in great detail, maybe you learn it a year before you fly, and then you do the experiment 5 months into flight, you're not going to remember. So the big shift from the shuttle world to the station world for us was towards more skills-based rather than task-based. So we want people to be really good with a screwdriver or forceps. We don't want them to know exactly what screw to turn, so that when it comes time to turn the right screw, you know how to do it with a screwdriver and not lose the screw when it comes out, because it will float away. And so that's really our big shift. We train a lot of very basic zero gravity skills, technically, both for medical experiments and physical experiments, and then we depend on very clear instruction. And another big thing for us has changed for space station is there's always a camera watching you. And you have to get used to people talking to you all the time. Hey, don't push the green button now, push the red button, dummy. Or don't lose this, or you've got something free floating here, you forgot to fix that down. So you work together. Your partner may be on the ground, actually. And so there's several things that make us work more efficiently in low Earth orbit that we didn't have before. Now that doesn't work when you go into Mars because the communication delay is so long that you have to be by yourself again, autonomous again. But we adapt to the mission.
What types of challenges or setbacks, if any, did you have on your way to becoming astronauts? Smooth sailing?
I'll tell this story. I got selected to be an astronaut and started training, and 3 months later I was diagnosed with cancer. That's a bit of a setback. I had my thyroid taken out, I had radiation treatment, but I wasn't thrown out of the program. We had some excellent flight surgeons, and these guys are two of the best that helped take care of me, and I think they represent the best flight surgeons in the world. And they helped me get healthy again, and I went through rehabilitation and training and went on to fly 4 missions. So that was a huge challenge at the time, just wondering, when I first heard the word, I have cancer, I thought, first thing, am I going to die? That's everybody who gets that diagnosis, that's what they think. The second part was, are they going to throw me out of the astronaut program? That was equally important. So that was the biggest challenge that I had along my way to make it to space.
I would have to say that our biggest setback was actually losing the shuttle Columbia in 2003 for a lot of reasons. You know, we are a very close-knit community, and these were dear friends, like brothers and sisters to us, and they were doing something we always knew was dangerous, but we had been doing it for so long without any problems or accidents. Nobody expected a problem, especially on landing. And I think the shock to us to lose our friends was huge. The shock to the program, we didn't fly again for 3 years after that, and everybody was wondering, what is the future of our space station? What's the future of our program, of the international partnership, all these things that we had worked so hard for. So I think that the very hard work that we had to go through to overcome that challenge, to make the space shuttle safe again, but to plan the flying out of the space shuttle program and to bring on new vehicles and whatnot, I think that was one of our biggest challenges ever that we all had to participate in.
You know, really, for everyone who's an astronaut, it is a story of challenges and setbacks. There's no one, very few people, if any, that have had a straight path to anything that they've striven for. You know, Don's story is incredibly inspiring. And every day in the astronaut office, I am inspired by the stories of my colleagues. I draw a lot of strength from them because I know just about whatever happens to me, somebody's been through something more difficult and has come through the other end. So For those who want to be astronauts, who want to attain something that's difficult to attain, just remember that indeed there's not going to be a straight path. There will be setbacks. You can overcome them. How you get there is going to be through a path that you probably can't predict. But persistence is the key, for sure.
So when you, okay. Great. Right. So when you are in training, when you have been selected and been training and then flying, so you really realize that actually this is not just an individual career, so just by yourself, it's a team effort, okay? It's a team effort with the crew during simulations and then during the flight itself. But you realize also that thanks to all the technicians and the engineers who are working on the ground 24 hours a day for you, this makes your dream come true. This is the possibility for you to realize that what you wanted. So I think the relationship between the people are very, very important in this job. Being able to fly, being able to realize experiments is something, but having actually this community between the team, the crew, and the people on the ground is also very, very important.
Michael, we spoke a little bit earlier, and I said that Helen has one hell of a question about the something you developed for the Mir supplemental medical kit, and in that regard, could you speak a little bit about the flight surgeons in Russia compared to you and the other guys at NASA?
So let me start answering that question with another question for you all. Suppose you land on another planet and you meet this race of aliens. You cannot speak to them very well, or if at all. And while you're there, you get a headache. And you start going like this. And your new alien friend looks at you and disappears and comes back with a cup of green fluorescent liquid with steam coming off of it and offers it to you. Would you take it? Yes, okay. Well, I probably would have too, but you shouldn't. When we first started working with the Russians, who are really our colleagues now, they had a very different approach to medicine. You know, the Soviet Union had just dissolved, and for the decades before, they had been almost isolated from Western medicine. So we approached medicine very, very differently. And when we wanted to start flying US astronauts on the Mir station, we had a lot of concern because we didn't understand the Russian medications or even their approach to certain medical problems. They certainly didn't understand ours. And so we decided to negotiate a supplemental medical kit. Now, it sounds very technical and maybe very logical to put a supplemental medical kit up there, but believe me, it was extremely difficult because it was the focus of a lot of negotiation and discussion about the relative value of each system's medical approach. It was very sensitive, actually. And so we came through that. That was one of the big challenges, actually. We came through that understanding each other much better. But that was difficult. It took actually a couple of years to get that together. Now, since then, we have learned from them, they have learned from us. There are some things they do better than us, no question about it. Some things we do a little better. And that was really the start of what became the joint medical approach that we have on the space station right now. And no country should ever feel like they understand all of human response to a new environment or the medical approach. And that's where we really started. Right now, I can tell you that the international medical groups that work between all the partners are extremely strong and well organized and well coordinated. And that was really kind of the beginning of it. So that was extremely useful for us.
Yeah, one quick question to Z'a'n-Z'aak as a miner. What are your views about future asteroid mining or lunar resources? And speaking on this topic, the ratio between human beings on the ground and robotics.
Okay, this is a very interesting questions because this will be pave the way for the future. I always say to the people asking me questions about exploration for the future, what is the relative part of the program which should be automatic, robotic, or by humans. And my feeling is that both are complementary, of course. We have to start with robotics because it's easier, but at the end, exploration means the presence of humans, okay? There is a difference between discovery and exploration. You can discover by robotics, you can discover new things on your computer, staying in your home. But if you want to explore, you have to be there. Okay, exploration means your presence there. So at the end, if we want to go further in the Mars exploration, for instance, we will need human missions. Okay, this is one thing. But now for the future, if we go back to the moon, you know that Europeans are pushing for the moon village concept, meaning that we could imagine to have a kind of a space station, but on the surface of the moon this time for months and so on. It is clear that these astronauts, in order to be able to survive, they should be as autonomous as possible, even if the Earth is not very far, but it's so costly actually to send things over there that we have to develop new technologies to use as much as possible the in-situ resources, okay? And this is true actually to produce oxygen, for instance, to breathe out of the regolith, okay? And just to give you an example, I'm working with my students who are now actually setting up a startup company, okay, on a process which will allow us to build a solar panel just out of the regoliths, the moon regoliths, and the solar energy, okay? So the idea, as being a miner somewhere, is actually to get out of the regoliths the silicon, which is there, okay, and do silicon crystals, and therefore develop the solar panels just out of the material that we will find there. The technology is changing a lot also, so everybody knows now the 3D printers, where you can actually develop objects or whatever by printing this way. We are developing printers for regolith, okay? Able to do out of the regoliths tools or whatever. And this is always the same idea. Try to use as possible what is on the planet you are exploring. This is true also for asteroids, where we can find very interesting materials, metals, and so on. And so I'm sure that in maybe 15 years from now, we will have commercial activities in mining asteroids and new planets or celestial bodies.
Z'an-z'ac, previously you mentioned the importance of a team.
Yeah.
So I have a question for everyone here. How was it with the team of the family? Was your family supportive? What did your parents think about you becoming astronauts, if they were still alive when they heard?
Okay, some of us have our wives with us, so maybe we can circulate the microphone. Well, in my case, I was lucky to be very well supported by my family, by my kids, and so on. But it is tough, maybe more for the family more than for us, because we follow our dream. We know what we want to do, etc., etc. The family, okay, the kids, the wives, and so on, actually, they have to accept more or less the situation. And at the end, especially for these guys who had longer training than myself, so we spent the last months preparing the flight 24-hour days, you know, and therefore for the family it is tough sometimes. So the family relationship with the rest of the family and with the friends and so on is very important also. So space exploration is a context in which the social relationships are very, very important.
I'd love to hear from some of the other astronauts as well, how their families experience.
So as Z'a'n-Zhak said, many of us have our wives here, so we have to be very careful about what we say. My wife, Michelle, and I have 5 children, and we're a very tight family, and I would just say that one of the hardest things about flying long duration is being away from your family. And when we fly, we start a phase of our mission, which is actually the end of a many-year process. So for the first 4 years before I flew, I was spending a lot of time in Russia, in Japan, in Europe, in Canada. So you're not at home during all of that time. So the separation doesn't start when you launch. It starts well before then. And it can be very haphazard, and as Z'a'n-Zhak said, they can be very, very long days. So you have to put that into your equation of assessing, is this the right thing for me to do? Because your family is involved there as well. So there are some things we do. We have members of the astronaut team that help one another. So we always have 1 or 2 of our own astronaut cadre that help take care of your family when you're flying. I flew and I had 4 teenagers and they were being teenagers. And it was really important to me to know that I had kind of brothers from the astronaut office helping my family through that. And another thing is when you're in low Earth orbit, we have really good communication. We can call any phone on the planet anytime that we have satellite coverage, which is most of the time. So I could call my wife every day, and I could call my kids when they chose to answer their phones, and help them with homework sometimes when they wanted help and whatnot. And so you're actually very connected in orbit. So in fact, more so than when you're in Russia training. That won't be true when you're on your way to Mars. You really will be separated, and it'll be more like ships from Europe, depending on letters that come a little bit later, a store and forward process. So yeah, all of those things have to factor in to your decision to fly and your career choices.
Like the others, I was blessed with a wife and daughter that completely embraced my career and desire to fly in space. Actually, my wife and I met in zero gravity. We were in you may have heard of it, the vomit comet. It was a jet that would take experimenters up. We fly up over the Gulf of Mexico and just fall a parabolic flight path. And you get about 25 seconds of zero G. You can do an experiment or whatever. We were both on one flight, and that's where we met. So our lives together started, incubated there at NASA. But the challenges are there. It actually is the most important thing, the thing you miss the most. Pizza is a distant second. But you miss your family more than anything else, of course. But there's, it really enriches the family in a lot of ways, a lot of great stories. My wife and I would talk every day, as Mike did, from space. But we never knew when the satellite was going to drop out, so we actually never said goodbye to each other. We would just talk until the communication was done. When it got back on Earth, we kind of didn't know how to finish a conversation. Are you going to say goodbye, or am I going to say goodbye? What's up here? But a lot of things have become part of the family tradition that actually are enhanced somewhat. Certainly without our spouses being as strong as they are, none of this would be possible without them.
And my wife is not here, so let me tell you the truth here. No, I think I'll emphasize the same point. The importance of the family cannot be understated. We are away from home quite a bit, training, traveling around the world. We're not there in space, and it really is our family. My wife took care of everything, with the house and made sure everything was in order. So I don't think we give our families enough credit. To our spouses here tonight, we thank you for the great jobs you do at home.
אפשר להעלות את האור טיפה?
We can't see you. Oh, now we can. Okay.
Hold on.
Let's get him a microphone. When I was
Check.
When I was at International Space University, we didn't call that volunteered. We called that voluntold.
All right, so we're here with the 30 kids, seventh graders from the Kfar HaYarok Junior High Space Engineering class. There's actually a thing like that. And I know these kids are striving to become space engineers, maybe astronauts. What advice could you give them? And maybe what advice would you give yourself as a seventh grader?
Great question.
Yeah, I think that I made the point earlier, but I would tell the students, you want to work hard in school every single day. And not just math and science. You want to do well in music and art and gym, in your languages, because you never know when something you're learning in one subject today is going to help you down the road. So I always tell students, work hard, do your best every single day, and to never give up on that dream. When I was about their age, maybe a little older, I would tell my friends, I want to be an astronaut, I want to go to the moon. They would laugh and say, you can't do that. Never listen to somebody who tells you you can't do something. So you keep that, that dream alive, you keep working hard, and you can accomplish, I'm quite convinced, anything you want to in your lifetime.
I'm sorry, I'm going to follow real quick. You do not have to be a genius to be an astronaut. We are living proof. And our wives will corroborate that. It really is about hard work. So the add-on to that is don't think that you're not smart enough. If you love something, if you care about it, you will become good enough at it. So just it's really hard work that's the key. That trumps genius every day.
Yeah.
Hi, my name is Amit, and I come from Nachshon. And I want to ask a question. What would you say is the main attribute to become a great astronaut?
What are the attributes to become a great astronaut?
Yeah,
Well, none of us are great astronauts, so I'm not sure we can tell you.
basic astronaut.
So the medium astronaut.
Good enough.
One thing that I've always looked at as a flight surgeon and as an astronaut, I'm like, how are astronauts similar? What are we? In what ways are we alike? I think one attribute of an astronaut is that we love to work. We are also incredibly curious people, and almost every astronaut you talk to loved what they did before they became an astronaut. And you see them, they're waiting for years for a flight, they're in training. Ask them about their job beforehand. Their eyes light up and they go, oh man, it was so cool. And the veterinarian that Z'a'n-z'ac talked about, he would talk about all the animals he worked with and he would imitate the animal noises. And it's just hilarious. And so almost everyone fell in love with something in science and technology and loved it so much they were willing to devote their lives, their professional careers working for it.
But I would also... Go ahead. One of the greatest attributes of what I would consider a great astronaut is the team thought, thinking about your being a member of a team doing something wonderful, and that isn't always exploring something new. That may be taking out the garbage without being asked, or washing the dishes, or helping people get through their daily life. Because again, you will be locked in a small place for many months with that person. So the combination of loving to learn and looking after each other as a team for the success of the team is really, really important as well.
Yeah. We all know a certain gentleman, his name is Dwayne Ross, and he is for a couple of decades, he reviewed every applicant when they came in for their interview. And I asked Dwayne, I had a moment alone with him after I'd become an astronaut. I said, so Dwayne, what do you look for in an application? Now he's seeing the applicants as they've filtered them down to they're very good in their fields, et cetera. But Dwayne said, I want to see if they're nice. And that kind of summed it all up. Is this somebody that you would want to work with? And that to me means relationships with people, both work colleagues and those close to you, are incredibly important. You won't be able to get to be an astronaut, certainly not a great astronaut, by yourself. And the great ones know that for sure.
Hi, my name is Tomer. I'm here from the 7th grade group. And I wanted to ask about when you're in space, what about jet lag? Are you like tired differently? Like how does it feel?
I'll talk about jet lag. We're traveling 27,000 kilometers an hour around the Earth every 90 minutes. So our day from sunrise to sunrise is only 90 minutes. But we work on a 24-hour schedule up in space. And I would base my time on the time in Houston, at the Johnson Space Center there. And we work on 24 hours. So we get 8 hours to sleep, an hour for lunch, an hour to exercise. So we're in a normal routine. But in space, we need to shift our times. I would launch on some of my missions, and then over the next couple of days, they would want us to go to bed an hour or two earlier every day so that the lighting conditions were ideal for landing, for example. So we would have that kind of a jet lag or time shifting that you'd have to do, and it was very difficult. You go to bed 2 hours earlier for a few days, and comes bedtime, you're just not tired. So it was very difficult. You had to force yourself to sleep in space because you had to be well rested in the morning so that you did not make mistakes. If you get tired, you make mistakes that can harm you, can harm the mission. So we worked really hard on disciplining ourselves and trying our best to get sleep, using sleep medications if you needed that. But we definitely had to deal with jet lag. Both before the mission, we would shift our time, and then when we come back to Earth, we got to get back to the normal daylight, nighttime cycle as well. And that was a challenge.
Jonah had a great formula, which is stand up, because we hear your voice from heaven, but we can't see who you are.
Yeah.
Perfect.
So I wanted to ask about the variety of subjects you learn. Like, you have to learn about space in university if you want to be an astronaut, because I'm wondering what I will learn in the future, and I really like space. And so just like wanted to ask what you learn in university or what you can it's like you want to be in space. Thank you.
So you mean what is some of the best things to learn in university? I would say there's no right answer for everyone, but certainly probably more than one thing would be important. For the near future, certainly the next few years, it's going to be science, technology, engineering, mathematics, medicine, that sort of thing. But a decade or more from now, it could extend into the arts, languages, law as well. But I don't know, what else?
So when you look at the things that are important for spaceflight, you find a very diverse background in the astronaut group, and that goes for cosmonauts and ESA astronauts and ourselves. We have engineers, we have lots of engineers. We have chemists, we have geologists, we have medical doctors, we got veterinarian, we have military people. All of these can be very useful. We bring all these different skill sets to the table, and then everybody learns generically the common knowledge that we need to fly the vehicles that we have. So like Tom said, there's not really a right answer necessarily. The answer is personal for you. You find something that's useful for spaceflight, hopefully something you love very much, that you want to get very good at, and any one of those fields would be very useful to us.
If I was 15 years old or so right now, I might also be thinking about taking a course in Mars geology, just to show the selection board you're interested in that. Little subjects like that, learning another language that you may speak with a colleague on your mission. Probably 10 or 20 years ago, we would have recommended to people applying to be an astronaut, take some Russian. That'll help you in the selection. Today, I would say, take some courses on maybe an asteroid mining, on planets and maybe Mars geology. I don't think that could hurt you at all. I wouldn't necessarily major in it, but just take a few courses just to learn a little bit more about it. NASA likes people with broad experience, broad education that they can bring to the table.
Can I just add on that for the Israeli for the Israelis in the audience here, that the Israeli Space Agency has a scholarship that they send a few people to the International Space University every summer. So that might be something relevant for some of you guys.
Check. Hi, I'm Tom. I'm from 10th grade. I wanted to ask if there was a point where you just said, I'm tired of this place in space, and you just said, I want to go back to Earth.
You can't really do anything about it, even if that happened.
I got to say, on my 4 missions, the last day when we're coming back to land, nobody was crying about it. You know, sometimes you go on vacation and it's kind of sad, you're at the last day, you have to go back to the job. But on my missions, nobody was saying, oh, let's stay up here another day or 2 days or a week or a month. Everybody was excited about the opportunity to come back to Earth, to see your family again, to get a nice hot shower, to get that pepperoni pizza I was talking about. You know, it was a great thrill for me always to come back to Earth. You know, to be back on this planet. Space is wonderful. It's a beautiful environment. We all had great experiences up there. If people ask me where I would prefer to live, in space or Earth, there's no competition. You know, this is the place you want to live. This is where our families are, our friends, you know, great Israeli meals that we've been enjoying here. So this is the place to be, is on Earth.
Okay, hi, I'm Ila from the students who built the satellite. And I was wondering about your early jobs before you became an astronaut. What were they? And would you go back to that?
Well, so I can start. My job before that was similar to Tom's. I was a medical officer, a flight surgeon at NASA for 9 years before I went to the astronaut office. I loved being a flight surgeon at NASA because I got to work with astronauts. I got to still fly the training jets. We were among the last to see astronauts when they launched. We were the first to see them when they landed. We worked from mission control. Those of us who wanted to got to do some science. We got to do development work. Tom and I both worked to build the relationship with the Russians as flight surgeons. And I will tell you honestly that for the first 5 years I was an astronaut, I missed my old job more than I liked my new job. Now, part of that was because of our 3-year flight delay, but I really loved that job. So I could easily see potentially going back to doing some kind of space medicine when they tell me I can't fly anymore. But everybody's different.
Hi, my name is Ori. My question is, it's kind of a dilemma. I wanted to ask whether you think is universities the only way to learn the skills needed to be an astronaut, since in today's world there are so many new ways to get knowledge from people that are much more reachable, from books, from online courses. University is not always the best way to gain the most updated knowledge.
Not sure I understand that.
Well, let me, just to clear something up, the skills you need to be an astronaut, nobody learns those before they get selected as an astronaut. You don't get selected and fly tomorrow. You get selected and it's like going to graduate school again, all over again, and it's years of training. So what we really want is for someone to bring, again, a set of skills that's useful to us, and then we'll train you to be an astronaut, knowing those background skills that are useful to us.
There's one thing we haven't mentioned is some of them, well, two things really. Astronauts tend to be people that, or need to be people that make decisions based on limited information that have consequences. Putting right now, in terms of your education, putting yourself in a situation, whether head of a club or something more than that, where you have to make decisions that have big consequences, and knowing how that feels to be under that kind of pressure, even if you don't have the information you need to make the decision. Learning what that feels like. That's very important. Also, I had a lot of jobs. I was about to answer the other question. I worked in a lumber yard. I painted houses. I used to take care of people's lawns. I made sculpture for yards. I've had a multiple number of jobs. And the manual labor, being an astronaut is at times manual labor. You have to be a mechanic. Spacewalks are brutal. They are, people say that they're an honor, but they're definitely not a pleasure. When you get out, you kind of beat yourself up when you do a spacewalk. And somebody that could rebuild an engine of a car, that would be a skill that'd be great when you're an astronaut. So that whole array of skills would be important, not just what you might learn in a course.
Okay. So since I don't want, any fight, I'll take the last question if I can. So my name is Elliot, and I'm from the Yuval Naaman workshop. And my question is first of all one of you planning to go to space again very soon? And if yes, will the next challenge be to eat the first hummus in the space?
Hummus. Eat the first hummus in space?
Well, it's already been eaten.
Yeah, well, unfortunately, I had hummus on my
I did
mission,
too.
and so did Tom. So,
No problem.
And I don't think we were the first.
So if hummus happen, what will be maybe the next dish, to have for the first time in space?
So, young Dr. Marshburn and I are still active astronauts, and we would love to fly again.
I think everybody would.
Everybody would, absolutely.
You want to go back.
And we've already had pepperoni pizza, and we've already had hummus.
We had goat cheese on board also. In my case.
Goat cheese, oh yeah.
Well, we've actually had espresso on board as well. We flew
Something French, though.
Yeah.
Champagne. Champagne.
We can't, beer, champagne, and some of those would be good.
Cognac.
That's something I would have to think about a lot, because there's no food that I don't like, so I'm a problem.
Yeah,
with
the
that.
worst meal I had in space was awesome. I really love to eat up there. What if it...
I knew Ilan Ramon and the crew because as a medical officer, before I went to the astronaut office, I was working some of the payloads that the crew was training on, and I continued to do that after I joined the office. So I knew everyone on that crew very well. I think the only time I knew Ilan Ramon was as part of that crew, and even more than most crews, that crew was very much like a family. They got along incredibly well, and they laughed all the time. I mean, to me, Colonel Ramon was a very serious pilot, but he, like all of them, about every 3 minutes, they all broke into laughter because somebody did something funny. They were like a family. And that mission was delayed so many times, and most crews would have been very disappointed, but for them, it meant more training together, more being able to be together, and it was really great. One of the stories about the crew is that there was only one serious crew member, Kalpana Chawla, who's also a dear friend of mine, and she would often say to the crew, okay, no more comedy, and they would all break into laughter when they did that. Ilan was definitely one of those people. So my best memories of Ilan are as part of that family, and that includes all the family members of those crew as well. So he was an amazing guy.
You ever have a life-threatening situation or feel fear?
Blue in space.
Yeah. Yeah, there's something about sitting on a big pile of explosives that kind of getting ready to launch that feels life-threatening. Certainly maybe it's a common feeling approaching your rocket when the team that got the rocket ready for you, they're all going that way, and you're the only one that's going that way towards the rocket. That's quite daunting. And when you approach your rocket, which seems alive, the space shuttle in particular, it's got steam coming off of it, it's got ice, and it's you can hear it. It's kind of grumbling. That can be quite daunting. the excitement of going to space by all means overcomes that. I think those of us that have done spacewalks, same feeling, going out the hatch for the first time. There's an element of fear there for sure, but you learn to rely on your training and just focus on that.
I would add one thing is that my biggest fear was making a mistake. I would say that most astronauts are more afraid of screwing up than blowing up because you're so focused on your task. That's where your thinking is. Even when you're doing something dangerous, you're not so focused on the fear. But if you make a mistake up there, the consequences can be very big. And I remember for me, that was always my biggest fear. Of when I made a mistake?
No.
Never made one. No, but certainly. I wrote down every mistake I made. And when I landed, we had one of our shuttle commanders who was very inspirational to me. He's not a very personable or warm, fuzzy person. We all know who we're talking about, Rick Sturkow. But when he landed, he was briefing to the office and he said, "We're going to tell you everything we did wrong, but I'm not going to allow anybody to say anything bad about my crew because I owe my life to them." And that was so inspirational to me that I wrote down every mistake I made and I reported it because we want to make everybody better. And I definitely made a few. Fortunately, none of them were dire or life-threatening. And that's how we train one another. That's how we teach one another because you can't read this in books.
Thank you.
Okay, so we are running out of time, so we just want to say a big thank you for all to come to this conference again. And for the people that will come tomorrow, we have another full day of fascinating program. So thank you and have a good night. Thank you.
Thank you.